half-life is the amount of time required for 1/2 of the nuclei of a radioactive sample to decay into products. So how long does it take for 1/2 of the nucleus to break down, to decay, and leave us with some other side products? There's a couple of ways to look at this. And it is an exponential decaying process. So if we start out with 0 half-lives, our amount remaining is our initial amount. So this O right here, this A sub 0, this sub 0 means that nothing has changed. So it is our initial amount. At 0 half-lives, we have not lost any of our radioactive sample. Nothing has started to decay yet. If we look at it in exponential form, 1/2 to the 0 is just going to be 1. So 1 times our initial amount is our initial amount. So we haven't changed anything. After 1 half-life, you have cut your initial amount in half. So it's your A naught times 1/2. You've broken it down by half. If you look at it in exponential form, your number of half-lives is going to be this exponent here. So we've decreased it by 1/2 one time. 2 half-lives, you're going to take your A naught times 1/2 times 1/2. So we've decreased our initial amount by 1/2 2 times. So when we look at our half-life, if we have N as our half-lives, your amount remaining is going to equal your initial amount times 1/2 raised to the N. But just raising it to the N doesn't give us enough information. We have to take into account how long something has been there. So N is going to be the time elapsed divided by the half-life of the substance. So our final formula is going to be A equals A naught times 1/2 to the little t over big T. So this is an exponential form here. It's not to the side, it is an exponent. A is going to be your amount remaining. So that's what we're going to end up with. A naught is your initial amount, and those two need to have the same unit. Grams, milligrams, whatever one amount's in, the other amount has to have the same unit. Times 1/2 to the little t over big T. So that little t over big T is the exponent to the 1/2. And little t is going to be time, big T is half-life. And again, these two have to have the same unit. Your times need to be the same. So if your time is in seconds, your half-life needs to be in seconds. If your time is in years, your half-life needs to be in years. Amounts have to have the same unit. Time and half-life need to have the same unit. Now, we do need to use logarithms, and I know some of you have not gotten to that. It's in a different level math class. But we're just going to go over the basic use of them here. Logarithms help us solve for an exponent by bringing that variable out of exponential form. So it's going to bring the exponent down. So if you have x equals y to the z, if we take the log of both sides, whatever you do to one side, you have to do to the other. It's going to bring this z down and in front of where you wrote log, so that you end up with the log of x equals z, so this guy moved to in front here, log y. So this logarithm is bringing that exponent down. You can't cancel logs out when they're over top of each other because it is changing the function of this number. So essentially this would be in parentheses like this. So if you have log of x over log y, you cannot cancel those two logs out. You have changed the value of x and y by applying a logarithm to them. So you're just going to type the function in on your calculator. So that we wind up with our final formula, A equals A naught times 1/2 to the t over t. And we will look at some examples in class.